Okay, folks, this video here is going to talk about the properties of a circle. Some of you may not need to know much more than words like diameter and radius, and some of you need to learn words that are like chord and, I don't know, central angle and inscribed angle. So stop as you need to, but I'm just going to start and use what you need, okay? Sorry about that writing right there. I tried to do underlining, and if I can't even do that properly, how am I going to show you some beautiful artwork inside this beautiful circle here? Speaking of circles, aren't they beautiful? Many cultures use them. Here in Canada, First Nations people have something called the Four Directions, and it's a really nice way of explaining different concepts and different thoughts about both spirituality and culture, and it's very cool. Circles are really neat, and so I kind of like this unit in math just because we get to deal with a circle. In this case, we're dealing with the properties of a circle, and there's some cool things. For example, if you had a piece of paper and you were asked to find the center of a circle, one thing you could do is just fold the paper right, fold it right in half so that you have a circle on each side. So you've cut it in half, and then do it again, and you would come up with the center of the circle. That'd be pretty cool. If you don't have that, let's say you have a protractor. If you were to draw this thing here is called a chord, okay? A chord is any line in a circle, okay? Any line that goes somewhere in that circle from end to end. Not through the middle, because that's the special line called a diameter, but a line just like this. And if you were to cut this in half, this is called a perpendicular bisector. If you were to cut this in half and just draw a line through there, that's called a perpendicular bisector because it cuts it right in the middle in between this line, and it cuts through at 90 degrees. And if you were to do that anywhere else on the circle, I'm just picking a random spot, and if you were to do a perpendicular bisector of that, you would end up finding the center of the circle. As long as you were able to come up with two 90-degree angles on chords and then perpendicular bisect them. Okay, now what else do we need to know? So we know what a chord is, we know what the center of a circle is, we know how to find the center of a circle. Any line that goes, this is a popular one from a young grade on, any line that cuts through the center of a circle is called the diameter. Okay, that one is an obvious one that many of you already know. Okay, let's see. So if you have a chord, and here's the center of the circle, let's say we knew that was the center, and you have another chord over here, which chord is longer? Well, obviously this one's longer, right? So complete this sentence. As the length of a chord increases, the distance from the center, so the distance between this chord and the center, does it increase or decrease? As the length of the chord increases, the distance to the center, it decreases. Because the longest a chord can be is a diameter, which is when it cuts right through the middle. Okay? Let's see. If a chord is equal length, let's say you have this chord and it's equal length to this chord right here, what can we say about their distances from the center? What can we say about these two distances? Well, we would say that they are the same. These two distances, these two chords are the same distance to the center because they are the same length. Okay? Let's see, I'm just looking at a piece of paper, and do most of you know what this means? When you have the center of a circle and you have a line going to the center, which is really half the distance of the diameter. Do you remember what this is called? That's right. It's called the radius. Okay? More than one radius, they call them radii. I'm not quite sure even how to say that. Radii. So that's what more than one radius would be. And let's draw another radius. Let's put another one like right here. Okay, so here's two radii. Instead of saying two radiuses, these are the same length. Now, here's some more words from this. When you have two radii like this, and the path, the distance along the circle, this thing that's created right here, this length here, wouldn't you say it's kind of like an arc? Well, that's what it's called with the properties of a circle. That is called the arc length, okay? So this is an arc, and there's an angle right here. Okay, there's an angle. I'm just going to put a theta there. But this angle that's created is called a central angle. Okay, that's another property. That's another property of a circle. Okay, so when you have the middle of a circle and you have a radius there, and pick another one, let's say right there, this is called the arc length. And this right here, this length from here to here, that's called the central angle. It's kind of easy to remember that one because this is the center. Okay? Try to fill in these sentences here then, folks. If two arcs on a circle, so here's one arc, okay, and here's another one. I'll just draw it over here. Let's pretend it's the exact same length as this one. These arcs have the same length. Okay? So if two arcs on a circle are equal in length, and if we were to connect them using radii, let's do that. Wow, my drawing's not perfect, but then the central angles for these arcs will be what? And we should say these would be the same. Okay, this angle and this angle would be the same. Does that make sense? Okay, let's keep moving along. If you were to draw, let's say, a chord, but not a diameter, but a chord, and then another chord just going anywhere, let's say, right there. Okay? This angle that's made, these chords meeting on the outside of the circle, this angle right here, this angle is called an inscribed. We're almost done this video, by the way. Oh boy, I can't spell properly. Inscribed angle. This is called an inscribed angle. Okay? If we had a chord here, and if we drew two chords that start here and here and go to, here I'll draw different colors here. Let's say we went anywhere else on the circle, there and there. Guess what? This and this, these two angles are going to be identical. The only time they would not be identical, and I'll draw another one just for fun, still identical. Okay, these three angles are all the same. The only time it wouldn't all be the same is if you drew something like this down here. You can tell, you can even see it. Look at that angle here. These are all less than 90 degrees, and this angle right here is more than 90 degrees. So if they're on the same side of the chord that you've drawn here, if they're on the same side, like on this side, then everything you do when you connect chords to the ends of this chord at the edge of the circle, the angles here will all be the same. Okay? And there's another cool thing. If we had a diameter, and by the way, both of these, no matter what, are equal, so it doesn't matter where you go, top or bottom. If you draw a chord here and you draw another chord here, guess what angle this is always going to be? I'll do it again down here, and then I'll try and see if I can connect that. Can you see the angle that it is? It's going to be 90 degrees. When you have a diameter and you connect two chords from the edge of the circle to any point along the circle here or down here, you're always going to get a 90-degree angle. That's pretty cool, isn't it? Boy, all this stuff you didn't realize, eh? What else can I say? If you had, let's draw another inscribed angle. There it is. If you had an inscribed angle, here's our arc. Okay, so if you have an inscribed angle, which is this one, and if you do you remember central angle? And if you were to make a central angle that had the exact same points along the circle that it had to meet up with, so two radii here. Whoops, wow, that's so bad. I think I'm going to redraw that. There we go. And right here. This is our central angle. Which angle do you think is bigger just by looking? Well, the central angle is bigger than the inscribed angle. Guess how much bigger it is? This is pretty cool. It's always going to be this way. If you draw something like this and if you measure it with like a protractor, the central angle in this case will always be double the inscribed angle. I'm writing too quickly for this. Oh well. Inscribed angle. This will always be double the inscribed angle, or the inscribed angle will always be half of a central angle. Okay? I think that is all I want to say for now, except one last thing. Let's say you have a line coming on the outside of the circle, just touching it and continuing on, just a straight line going on forever and just touching that. And this is called, first of all, the name of this is called a tangent line. Okay, if it just comes along and touches the outside of a circle. And another cool thing is if you have, let's say, a radius of the circle and it touches the tangent line too, you're always going to get a 90-degree angle that's formed with the radius and the tangent line. Or you could say the diameter and the tangent line, where they meet, is always going to be 90 degrees along the edge of the circle. That's pretty cool, eh? It's impossible for that not to be true. Anytime you draw it, if you draw a line going right to that spot where it touches, you always get 90 degrees. You can't help it. Pretty cool, eh? Well, I think that's all I wanted to say because this video has gone on long enough. So hopefully you're okay with all this. And take what you need, because that's supposed to be a tongue. Because not all of you need the same things, depending on what math course you're doing. Okay? And have a great day.